Hello, Dr. Satish. Sorry we are a little late to the session. Yeah, I'll allow your mic. Just give me a minute. Yes, Dr. Satish, I've allowed your mic. Sorry.
Good afternoon.
Yeah,
Good afternoon.
yeah. Sorry, we are
Oh, no,
starting this session a little late.
yeah,
Is my screen visible to you?
visible.
Okay, I'll start right away.
Yeah.
Hello, everyone. Welcome to this session 11 weekly discussion and doubt clearing session 11 of the NPTEL course Maintenance and Repair of Concrete Structures NOC23-CE06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I'm Ashirvad Saptati. I'm a PMRF research scholar at IIT Delhi, and I am also the officially assigned teaching assistant for this NPTEL course. I take these weekly sessions where we discuss the week early assignment problems that have been given to you, which you have already submitted the answers of, and we also take some of the doubts that you might be having regarding the previous week's lectures. There is another teaching assistant to this course. His name is Umesh. He usually takes his sessions on Fridays from 7 to 9 p.m. and I take my weekly sessions on Saturdays from 6 to 8 p.m. And as mentioned in the previous session as well, I have pasted the link of the week 9 and week 10 sessions. The YouTube links have been pasted in the meeting chat. You can check it out. And I've also uploaded the meeting slides that we use during these sessions. So I've uploaded that to the OneDrive folder, which I have shared the link of. In today's session, we'll be covering 2 weeks assignments. One is the week 10 assignment 10, and this is going to be the penultimate session of this course. So we have another one session left, which we'll be taking in the next week, and we'll be discussing the week 12 problems. I guess the week 12 problems, the deadline is 19th of April. So we'll be discussing that in the coming week. In today's week, we'll be discussing the week 10 and week 11 assignment problems, and we'll be taking any of your doubts that you might be having regarding these week 10 and week 11 lectures or any of the previous lectures as well. All right, starting right away. The first question of the week 10 assignment 10 was choose the correct statements about dowel shear devices on roads. The options given are they transfer high vertical shear loads while allowing longitudinal movement at the joints. They transfer high vertical shear loads while allowing vertical movement at the joints. They prevent excessive stresses in the slabs by allowing independent longitudinal movements. They prevent excessive stresses in the slabs by restricting the independent movements. Yes, I guess Dr. Satish, you are the only person in
Yeah,
this
yeah.
meeting chat. Yeah, okay.
Yes, yes. This is basically meant for transfer of high vertical shear loads. So first option is correct.
Mhm.
Then
Right,
second one is not correct because vertical movement cannot be allowed.
right,
Uh, Excessive stress in the slab by allowing independent longitudinal movements. Yes,
right,
individual longitudinal movement does not disturb us. They prevent excessive stress in the slab by restricting the independent movements. So these two answers are correct.
right. Thank you, Dr. Satish. Yes, so this is the typical the schematic representation of a dowel shear bar that is given between two successive concrete castings. So basically, dowel shear bars are a form of expansion joints. In case of typically in concrete pavements, there are three types of joints that we come across in majorly. One is a contraction or a control joint. So, as the name suggests, contract in case of a control joint, we control the location of cracking. So, I'll just give a brief intro on this. We control the location of cracking. So basically, saw cuts or tool cuts are given so that they reduce the cross-sectional area and thereby um, uh, the crack occurs at these locations. Cracks are allowed at joints. Then there is another type of a joint which is known as a construction joint. Construction joint. So basically, there are construction joint is between two successive construction activities. That is to provide a between joint provided between successive slab castings or successive castings per se. So basically, when the construction is not monolithic in nature and the stretch of casting is kind of long or a large area has to be cast, then we carry out the casting in successive pores, and those successive pores have to be connected, and therefore we provide construction joints in between the castings, and they can be done typically by shear keys. So, like in the case of precast members, they contain these shear keys which provide for interlocking between the successive cast elements, precast elements, and then we provide tie bars. And why I want to discuss all this is that what is the difference between a tie bar and a dowel bar, and I'm coming to that in some time. So tie bars typically, since this is a construction joint, they don't allow any movement. So don't allow any horizontal or vertical movement. So they in fact prevent any differential settlement or differential movement between the successive cast members, and therefore tie bars are simply uh, ribbed bars, the ribbed high yield strength bars that are provided between two successive elements, and they act as construction joints. And the third typical type of a joint that is provided is an expansion joint. An expansion joint allow for the movement, allow for the movement in order to release stress. So whenever there is a stress that is getting built up inside the concrete due to certain environmental variations, like there is shrinkage occurring and there is temperature variation, so there is thermal stress getting built up inside the concrete. In order to release those internal stresses that are getting developed inside the concrete, we provide these kind of expansion joints, and one of the examples is a dowel bar. So typically, dowel bar is what is being shown here. It allows for horizontal movement, vertical movement is not allowed. So this is a typical schematic representation of a dowel bar, in which this is the dowel bar as shown, and then there is a ribbed case or a ribbed debond sleeve that is provided around the tie bar, so that it has a good bond between the concrete and the bar. So this ribbed sleeve is provided to achieve a good bond, because ultimately, uh, even if we want the concrete to move across, like due to expansion, the concrete can come closer, or due to contractions, the concrete can move further apart. But we want the dowel bar to be in that place, and therefore, for that purpose, we want the ribbed debond sleeve, which will act as a sleeve for the dowel bar, that has to be intact. So we want a good bond between the sleeve and the concrete, but we want a grease between the dowel bar and the sleeve. So this grease, the yellow portion is the grease, grease allows for the relative movement between dowel bar and sleeve, and this provides a good bond between sleeve and concrete, right? So the grease allows for a good relative movement, so that the dowel can allow for the horizontal movement to occur. During expansion, the concrete will come closer. During contraction, the concrete will go further apart, and the grease will act as a lubricant for that purpose. But again, we want the grease to be intact in that place. It doesn't leach out into the concrete. It doesn't flow out of the air, so that it will provide a good lubrication, and therefore we provide an extension cap. So there is an extension cap to protect the grease from leaching out. Sorry, it's getting clumsier as I am writing. And then there is a foam, which is this green portion is a foam, and this foam is basically a soft material, like any kind of a softer polymeric material, like we have seen in the polyurethane is forms of foam. So these kind of foams are provided so that they provide a good cushioning beyond the rebar, so that whenever there is an expansion, it has sufficient space to for the movement, but it also doesn't allow for a free space, so that there is no entrapped air. Otherwise, that entrapped air, when it comes in contact with humidity, that will affect the rebar, and that will cause for the corrosion of the rebar. So in order to not leave that portion empty, we apply a foam over there, so that it is an elastomeric material. It is not a stiff material. It will allow for the relative movement, as well as it will fill the gap, so that there is no air and humidity present at that location, to allow movement and restrict humid air. So this is the role of the foam. So this is the typical representation of a dowel and the functioning of a dowel bar. So therefore, yes, they transfer the high vertical shear loads, because they don't allow for the vertical relative movement, and therefore the stresses that is being built up due to for the application of loads are shared uniformly between both the different concrete elements. Yes, so this is a true answer. They don't allow the vertical movement. This, as Dr. Satish also mentioned, yes, this is a wrong answer. They don't allow for the vertical movement. They prevent excessive stresses in the slabs by allowing independent longitudinal movements. Yes, they are expansion joints, and therefore they're provided at the expansion joints, and they allow independent longitudinal movements, and they don't restrict the independent movements. So this is a wrong answer. All right. Moving to the second question. As per the lecture, what are the key mechanical and durability features of a good dowel shear device? And I guess we have covered most of it. But yes, Dr. Satish, do you want to answer this question? The options given
Yes, yes.
are, yeah, yeah, you can
This
answer.
it has to be corrosion resistant, first requirement.
Right,
Then, as you had discussed in the previous question, ribbed plastic sleeves with grease inside.
right,
Yes, and this is common to question number one also. Ribbed dowels, no, that's
right,
not the intention.
right,
Parallelly aligned dowels with minimum tolerance. Yes, that is also correct.
right. Yes. Thank you, Dr. Satish. Yes, so the correct answers to these questions are these three answers actually. So the first statement is dowel should be made with corrosion resistant materials such as stainless steel or FRP. Yes, because we don't want the dowel bars to get corroded. Otherwise, if these rebars get corroded, they will form the corrosion products will form around these rebars, and that will create expansive stresses within the concrete, and that will further create cracking. So if I'm looking at a plan of a expansion joint, and this is a typical expansion joint with this dowel rebars, if corrosion occurs, then there will be longitudinal cracks across this rebars, and that will affect the concrete. So that will further allow the ingress of water and other substances into the concrete, and that will lead to the deterioration. So these are corrosion cracks. We do not want that, and therefore we want the dowel bars to be made out of corrosion resistant materials like stainless steel or FRP bars, right? Then the second thing, as we discussed, ribbed plastic sleeves with grease inside. Ribbed plastic sleeves provide bond with concrete, and grease inside lubricates and allows movement of rebar, dowel rebar, right? We do not want ribbed dowels. These rebars are not ribbed because if we provide a ribbed dowel, then that will have, those ribs will act as shear keys, that they will provide shear resistance, and they will provide a good bond strength between the concrete. They'll increase the grip as it is mentioned, and we do not want a good grip between the between the dowel rebars and the ribbed sleeve, because we want to allow for the longitudinal movement, the horizontal or the longitudinal movement of the rebar in the expansion joint. Therefore, we do not want ribs. Rather, the concrete rebars, if they are made out of stainless steel, then they should not contain any ribs. They should be plain and smooth in nature, so that they will have a good, they will allow for a good relative movement between the two concrete elements. So this is a wrong statement. And finally, the last statement is parallelly aligned dowels with minimum tolerances. Yes, the ribs, when they, again, this is a plan. This is a plan we are looking at, and if this is a construction joint, so the ribs should be parallel to each other. It should not be like in a skewed manner, no, because that will not allow for the, that will prevent uniform stress distribution. So skewed should be avoided, and the tolerances, the pitch or the gauge length that between the rebars should be sufficient enough and should be minimal, so that there should be these rebars should be provided at sufficient spacings, so that they can I mean, they will be structurally possible, they will be structurally capable to allow for the uniform stress distribution between the two successive concrete elements. Therefore, these three are the correct answers. All right. Moving on to the third question, the figure below shows the repair work carried out on the concrete surface and the elastomeric bearing pad between the girder and the column of a bridge. Select the most relevant inference from the following options. And this is a uh, concrete girder, and this is the concrete column, and this is the elastomeric bearing pad. The options given are: the repair enables the bearing pad to carry, and we have to select the most relevant inference from this particular image that we are looking at. The repair enables the bearing pad to carry the compressive shear stress. Bearing area seems less than the top surface of area of the columns, which may lead to stress concentration beneath the pads. The bearing pad is flexible and its functionality is not affected by the repair work. Which of these statements is correct?
Second one is correct, because it is visible here that bearing area is much lesser than the area of the column top.
Right.
So it will lead to excessive stresses, stress concentration. So
Right.
they are asking for only one answer. This is the correct one.
Right. So, thank you, Dr. Satish. As we can see over here, the bearing pad doesn't cover the whole bearing surface between the girder and the column, and therefore, the effective transfer of the stress from the girder. So, if the stress is coming like this, let's say this is just a schematic representation, then the stress transfer will be only through the bearing pad location, only through the location in which, only through the region in which the bearing pad is present, and therefore since the area is reduced, the stress levels will increase. So this will lead to stress concentration beneath the bearing pad while transferring the load from the girder to the column, and that will lead to the failure of the bearing pads, and that might also cause a stress concentration in the column, which might affect the column structurally. It might cause damage in the column, structural damage in the column. So this is a stress concentration. So yes, this is the correct answer. The second. So the bearing area should cover the whole. So the bearing pad should cover the elastomeric bearing pad should cover the whole area of the bearing region between at the contact surface between the girder and the columns. The whole region has to be covered with the elastomeric bearing pad. All right. Moving on to the fourth question: what are the good practices to be ensured during the construction and repair of an expansion joint? The width or gap of the joint should be kept very minimal to restrict the slab movements. The joints should be filled with elastomeric materials or strips. Good drainage of water must be ensured. The entry of soil or other debris into the joint spaces should be prevented.
First one is incorrect because we want appropriate width of the joint,
Right,
neither minimum nor too not excessive.
right.
The joint should be filled with flexible material.
Hmm.
So second one is correct. Good drainage is a must because otherwise it will cause corrosion here and there.
Right,
Uh, and the entry of this physical obstruction is not desirable. So this is also correct.
right, right.
This should
Thank
be prevented.
Thank you, Dr. Suresh. Yes, these three are the correct answers actually. The width or the gap of the joint should be kept minimal. No, because we want an appropriate width or the appropriate gap to be provided between the two concrete elements, because we want to allow for the relative movement between the slabs while during the rise or drop in the temperature levels, or due to thermal stresses or due to any other kind of stresses. We want to allow for the expansion or the contraction to occur between the slabs, and therefore the width should be appropriate. It should not be less or should not be very high. If it is less, then the concrete slabs will lock against each other, and that will increase the stress at the location, at the gap location, and that will cause cracking of the concrete. If the gap is too high, then it will allow for the ingress of water, rainwater, and other the soil or debris or anything else to get inside, and that will um, clog that portion, that gap, and that will not allow for the effective expansion in the joint, expansion or contraction movement in the joint. So the gap has to be appropriate. So this is a wrong statement. The joint should be filled with elastomeric materials or strips. Yes, this is a right statement, because we want the gaps to be filled so that it will restrict the ingress of any water, or like we mentioned, the entry of soil or anything else. Now, but if we want to fill the gaps, it should also the material that we are filling the gaps with should be such that it will also allow for the longitudinal movement between the slabs during the expansion or the contraction processes. So elastomeric materials or the strips, what they do is essentially uh, they um, they are flexible enough, they're elastic enough, and so they allow for the contraction. So they themselves get contracted when there is expansion in the concrete, and then they also expand back to their original sizes when the concrete contracts. So these elastomeric strips are provided in the transverse direction along the length of the these expansion joints. So these should be provided. Also, sometimes these elastomeric materials come in layers, and they allow for the drainage channels to form through these elastomeric materials. So the drainage channels form in the transverse direction. And so I'll try to draw a typical diagram of an elastomeric strip. Let's say this is a expansion joint. So these elastomeric materials come in the shape of these. So they run across the length of this gap, and these are the channels for drainage of water. This is the elastomeric strip. So sometimes these elastomeric strips also, apart from filling the joints and acting as good elastomeric materials to allow the contraction and expansion between the concrete, they also have these morphological features, so that they can allow for the drainage of the rainwater in the transverse direction. All right. Then, yes, this expansion joint should have a good drainage of water, so that the water does not get accumulated in this gaps. Because if the water gets accumulated, it will get inside the concrete, and if the concrete is reinforced, if it has rebars inside, then it will corrode the rebars. So we want a good drainage of the water. We do not want the water to get accumulated in these gaps on the expansion joints. And then the third is the entry of soil or the other debris into the joint spaces should be prevented. Yes, because if the if debris or soil they clog these gaps or the expansion joints, then that will lock these expansion joints, and that will prevent the concrete from its longitudinal movement. So these three are the correct answers to this question. Moving on to the fifth question. One component polyurethane, or PU, injection technique can be used as a crack repair measure in an RC system. As per the lecture, select the appropriate choices. The statements given are: the PU compound reacts with air or water to form foam instantly. This technique can be used to restore the structural cracks. This technique can be used to repair non-structural cracks. Which of these options are correct, and why?
First one is correct because it will have reaction with air and water to form a foam. And then it cannot impart strength.
Right?
It can act as a barrier only. So it is not for structural purposes. Yeah, it can fill up for non-structural cracks. It is okay. If we want strength, it is not okay. We have to go in for the materials like epoxies, etc. for structural purposes.
Right, right. Thank you, Dr. Satish. Yes, so these two are the correct statements actually. So if it is a one component PU, basically these polymeric materials come in either one component systems or two component systems. In the case of one component systems, they contain the polymer or the resin itself, and it only requires water or air for getting activated and hardening. And in the case of a two component systems, there is a part A and part B. The part A is basically a resin or a polymeric substance, and the part E is a hardener or an accelerator. And these two are mixed in specific proportions, the mixing ratio has to be determined depending on the type of repair work that we want to carry out. And then when these two are mixed, they harden. They give the required hardening, the hardened property that we want from this systems. Now, if it is a one component polyurethane, then yes, the first statement is correct. It will only want or require air or water to form the foam instantly. Yes, it forms a foam. So this is a correct statement. This technique cannot be used to restore structural cracks because as the PU system forms only a foam, so it is a softer material, and it is only used for non-structural purposes because where there is leakage of water or any other non-structural fissures, these foams or these PU foams can be injected, and they react with water available over there or the air from the atmosphere, and they expand in volume, and they fill these fissures or the cracks. They fill these cracks and then come out once this PU systems are effectively injected inside the cracks. So if they completely fill the cracks, they will come out, so that we'll know that the crack is totally filled. But these are only temporary systems, and they can only fill the cracks for temporarily, like they can stop the leakage of water temporarily, and then again we have to carry out an injection using epoxy, because epoxy is a harder material. When it gets set, it becomes very hard, and it allows for a good bonding between the two regions across the cracks. So epoxy so whenever after the injection of the PU, when epoxy is injected, since epoxy is a harder material than PU, it will puncture these foams, the foam that is formed within the cracks, and it will fill those regions, so that first of all the water leakage is stopped by injection of the PU foam, and once the leakage has stopped, then only we'll be able to inject the epoxy, because epoxy is cannot set when there is water present over there, and so therefore epoxy doesn't behave well. It is immiscible in water. It doesn't behave well in the presence of water, and therefore for it to set, the leakage of water has to be stopped first, and therefore PU injection is done first, and then epoxy injection is done later, and then this will complete the total repair work. And this is the if only PU is injected, then that is only to stop a small crack, the leakage of water across the small cracks. So these are if only PU is getting used, then that is to repair only the non-structural cracks. If you want to carry out a structural crack repair, if there is no leakage of water, then you can directly go ahead with epoxy. But if there is a leakage of water over there, then you have to first stop the leakage of water using PU, then you can carry out a epoxy repair. So in this case, these two are the correct answers, right? Moving on to the sixth question. In a pre-stressing system, gradual failure of strand could result in a shorter redevelopment length than sudden impact failure of strand. Is it a true or a false statement, and why?
This is true. It was told in the lecture that in case of impact, uh, it requires longer redevelopment length.
Right,
Where in case of gradual failure of strand, it requires shorter redevelopment length.
right. Thank you, Dr. Satish. Yes. So basically, what is development length, and we'll then go for redevelopment length. When in case of a pre-stressing system, pre-stress is applied to the strand, right? Applied to the steel strands, and when uh, the stress is released, this pre-stress gets transferred this is when the stress is applied to the steel, that is a tension, and this pre-stress gets transferred as compressive stress in concrete, right? Now, when this pre-stress is getting transferred from the strand to the concrete, if we look at this is a typical section, longitudinal section of pre-stressed element. And if it is the end, this is the end of the pre-stressed element, then the length required for the effective transmission of the pre-stress from the steel strand to the concrete is known as the transmission length. So in this length, the stress starts to get transferred from the end of the member, and at this length LT, which is the transmission length, the whole of the pre-stress has been effectively transferred to the concrete. And then there is a bond length required for the effective stress to be achieved till the ultimate stress. So there is a transmission length, and apart from that, then there is a bond length required for the effective stress to increase till the ultimate stress inside the concrete. So the summation of the transmission length and the bond length is known as the development length. And when there is um, there is a gradual failure of the strand, the requirement for transmission length gets increased, because there is a failure. If there is a failure of the pre-stressing system, the pre-stress in the strands gets released. It gets reduced due to let's say elastic shortening, or due to loss of pre-stress due to time, or due to creep and relaxation. Also, these different types of failure, or due to deterioration of the strands, maybe due to corrosion also. So the effective pre-stress in the strands gets reduced, and therefore the development length required for the effective stress to be transferred to the concrete increases. And therefore, whenever we are carrying out a repair work in the pre-stress system, the total the pre-stress systems need to be detensioned first if there is a residual stress remaining, and then we have to splice the pre-stressing strands, and a sufficient redevelopment length has to be provided, and proper calculations have to be done, so that the stress can be effectively transferred from the strand to the concrete, and therefore a sufficient redevelopment length needs to be provided while splicing the strands. Now, it has been observed, as also mentioned in the lecture, that in case of a sudden impact failure, the redevelopment length required will be longer than in case of a gradual failure of the strand. Let's say due to corrosion, or due to other deterioration mechanisms. If there is a gradual failure of the strand, then the redevelopment length required during the repair will be shorter as compared to if there is a sudden impact failure, let's say due to some accident, or due to some other damage mechanisms, like environmental environmental loads, like earthquake, or any other uh, natural calamities that might occur. So yes, this is a true statement, right? Moving on to the seventh question. As per the lecture, select the correct methods of detensioning of tendons. Jackhammering behind the anchorages, drilling into strand, burning through the strand.
It was told in the lecture that jack hammering is not allowed,
Right.
and the other two are suggested. We can
Right.
drill into the strand, we can burn through the strand also. So
Right.
second and third are correct.
Right. Thank you, Dr. Satish. Yes, as per the codal provisions, jackhammering behind the anchorages is not allowed for detensioning of tendons. So whenever we are carrying out a replacement of the tendons, or we want to carry out a splicing of these pre-stressed tendons, we have to first remove the residual pre-stress that is already present in the tendons, and that is, this process is known as the detensioning of the tendons, and this has to be done from the given options. This has to be done by these two options only. The one is drilling into the strand. So by drilling into the strands, you're reducing the cross-section area, and therefore you're detensioning the tendons. And one is through burning through the strand. So by burning, you're increasing the temperature, and therefore increasing the temperature will reduce the pre-stressed and detension the tendons. So these two methods are acceptable. The answer to this question is drilling into the strand and burning through the strand. All right, this ends the week 10 assignment 10 problems. We'll again discuss the week 11 assignment 11 problems. The answers to this assignment has already been submitted by you, and the deadline is over, so we can discuss this. The first question of this assignment was, the photo below shows the repair work conducted to strengthen the column of a commercial building. Observe the photo and select the correct choices. Note CFRP is carbon fiber reinforced polymer. And the statements, this is the photo given at this at the side, and the statements given in this question are: CFRP bands are wrapped to enhance the shear strength of the column. CFRP anchors are used to prevent the delamination or debonding of the laminates. Near surface mount cut and CFRP inserts are provided on the column to improve its compressive strength. L-shaped CFRP laminates are provided at the top to enhance the punching shear resistance of the slab. L-shaped CFRP laminates are provided at the top to achieve sufficient junction development for adequate load transfer from the slab to the column. Which of these statements are correct?
First one is correct. Wrap to enhance the shear strength of the column.
Right.
Yes. Then prevent delamination, demoulding, anchors. Yes, anchors will are to be used.
Right.
Then this near surface mounted cut appears to be glass fiber and not this CFRP. So L-shaped enhance the for punching resistance. You have to provide extra depth. So
Right.
that is not the case.
Right.
So last one is correct because for junction development, CFRP laminates were suggested in the lecture.
Right. Thank you, Dr. Satish. Yes, you have rightly answered it. So these CFRP bands that are provided laterally, they act as lateral ties, bands, and they typically function as lateral ties in columns, and therefore they increase the shear strength of the columns. Right? So yes, this is a correct answer. Then CFRP anchors are used to provide delamination and of the laminates or debonding of the laminates. Yes, we can see over here also there is anchoring, and if it is not also visible in the picture, so basically these CFRP the CFRP laminates have at the end they have these wires coming out, the laminate wires, and they can be, as we have seen in the previous lectures as well, they can be anchored by spreading out these wires on the concrete surface and then applying a coat over it, so that will allow for the anchoring. So yes, CFRP anchors are used to prevent the delamination or debonding. Near surface mounted cut and CFRP inserts are provided on the column to improve its compressive strength. No, this is not the case in the given picture. And L-shaped CFRP laminates are provided at the top to enhance the punching shear resistance. Punching, as Dr. Satish also mentioned, for punching shear resistance to be increased, extra depth needs to be provided. And as we can see in this flat slab system, there is no extra depth provided over here. We have only provided these L-shaped CFRP laminates, and they do not enhance the depth or enhance the effective shear cross-sectional area for the punching shear resistance to be increased. and therefore this is not the correct answer. The last answer is again correct. These L-shaped CFRP laminates rather provide sufficient junction development between the slab and the column for the adequate load transfer. So these L-shaped CFRP laminates are to provide, they provide a good junction between the column and the slab, so that effectively the moments and other loads can be redistributed effectively to the column, from the slab to the column. So an adequate load transfer can be carried out between the slab and the column. So these three are the correct answers to this question. Yes. All right. Moving on to the second question. The photo below shows the repair work conducted on a bridge girder to protect the reinforcing steel from corrosion. The repair steps involved surface preparation. This is one of the repair methods. Then there is grit blasting. Then there was zinc rich primer. Primer coat was applied on the repair surface, and finally application of the sacrificial nodes. So these were the repair steps that were carried out in this image. What is the redundancy of the adopted approach and how? Yes, can somebody answer?
You know, first one is surface preparation only, that is a prerequisite, not a treatment itself.
Right,
Grit blasting is again a prerequisite for the treatment. Zinc rich primer is a treatment, so that is first line of defense, and sacrificial anode again protects. So there are two protection systems available. So
right,
one is additional. So redundancy accordingly will be one.
right. Thank you. Thank you, Dr. Satish. Yes, so as he has rightly mentioned, surface preparation has to be done in any kind of a repair technique that you are adopting. The surface has to be prepared well, the surface has to be cleaned and free from any debris or any dust, so that whenever we are carrying out a repair work, the repair material and the substrate concrete have to develop a good bond. For them to develop a good bond, the surface has to be prepared well before applying the repair material. So this is a prerequisite, as Dr. Satish mentioned. Then there is grit blasting. Again, the applying of a grit blasting before applying a primer will ensure a good bond between the primer and the concrete substrate concrete, and therefore this grit blasting is applied to develop a good bond. So this is again a requisite technique, and it is not a corrosion protection system yet. But the third one, application of a zinc rich primer, is a corrosion protection system. When you're applying a zinc rich primer on a concrete surface, so it will act as a sacrificial anodic protection, or a galvanic protection system. So applying a zinc primer will provide a sacrificial anodic protection system, because the zinc that is present in this primer coat will get corroded while protecting the rebar inside the concrete structure, as we have also discussed in the previous sessions as well. And further, at the end, they have applied sacrificial anodes, and these sacrificial anodes are typically zinc anodes, and they are also a similar kind of a system. Only the difference between a zinc rich primer and a sacrificial anode is that the sacrificial anode is dynamic in nature. It can provide a current as per the demand of the concrete with the due course of time as the corrosion proceeds in the zinc, and the demand in the concrete, the current demand in the concrete fluctuates. It will act accordingly, it will provide the current accordingly, and therefore it will let the zinc anode corrode at a pace which is required by the concrete to protect the rebar inside. However, in case of a zinc rich primer, it is not a properly designed sacrificial anode cathodic protection system, or SSCP system. It is just a primer coat that has a zinc rich material, and it will just once this zinc gets consumed, once this zinc gets corroded, it will not be able to protect the steel rebar anymore, and the steel rebar will start to corrode. So these kind of zinc-rich primer coats have to be applied at regular intervals to protect the steel rebars inside. However, for sacrificial nodes, these are specifically designed systems, and we can actually predict the time or the lifespan of these sacrificial anodes, and we can apply as many the number of anodes can be directly calculated as per the current demand of the concrete. So since these two systems are both cathodic protection systems, or they act as sacrificial anodes, or they provide galvanic protection, therefore the degree of redundancy is 1 over here, because one is if one is already provided, it is already protecting the steel rebar, and therefore an additional protection system will act as a redundant system. So the redundance degree of redundancy in this case is 1, right? Answer is 1. The third question was, as per the lecture, an instantaneous corrosion rate of less than 1 milliampere per meter square indicates that the steel is passivated. Is it a true or a false statement? It's a straightforward question.
It is true. As per ISO guidelines, as told in the lecture, if corrosion current generated is less than 1 milliampere per meter square, we can call it as a passive state of steel. So
Right.
it is true.
Right. Thank you, Dr. Satish. Yes, this instantaneous corrosion rate, or ICOR, if it is less than 1 milliampere per meter square, then the steel can be considered to be passivated as per ISO guidelines. So this is a true statement, right? Moving on to the fourth question. Select the long-term characteristics expected from an adequately done repair using sacrificial anode cathodic protection system in reinforced concrete structures. Refer to this as SCP. The statements given are: it should supply high current density throughout the design life, irrespective of the demand from the reinforcement. It should be self-regulating. It should favor the passivation of the embedded steel reinforcement. It should favor the passivation of the sacrificial anode metal, which is zinc. Which of these statements are correct, and why? Yes, can somebody answer?
No, first one is incorrect because current demand will be lesser with passage of time.
Right.
So it should not supply high current density all the time. It should provide as per requirement.
Right.
Then second one is it should be self-regulating.
Right.
Yes. Then third one is it should favor passivation of the embedded steel. Yes, that is the requirement. And it should favor the passivation of no. It should sacrifice itself
Right.
in order to protect steel. So last one is not correct. So middle two are correct.
Right. Thank you. Thank you, Dr. Satish. Yes, the correct answer is the sacrificial anode cathodic protection systems are basically zinc-based anodic sacrificial anode systems, which are embedded uh, in a encapsulating mortar, or a very highly alkaline mortar, cementitious mortar, which provides alkaline environment beyond a pH of around 13, so that it allows for the zinc to get corroded, and these are in connection directly with the steel rebar, so there is no external voltage applied. Rather, these sacrificial anode metal systems are self-regulating, so they, as per the current requirement from the steel reinforcement that is embedded inside the concrete, these um, sacrificial anode cathodic systems, protection systems can get corroded, and they'll supply for the current demand. They'll meet the current demand of the reinforcement with the due passage of the time. So yes, they should be self-regulating, and the supply of the current should not be high throughout the design life, because that will uh, um, accelerate the corrosion of this sacrificial anode metal, and that will get consumed within a few years. So we'll have to replace it. So that does it. The SSCP systems don't act that way. So this is a wrong statement. In fact, as per the demand, it should regulate itself so that it will get consumed for a longer duration. So, and yes, the second statement is true. It should be self-regulating. The third statement is true. It should favor the passivation of the embedded steel reinforcement because while since this is basically a galvanic protection system. So this essentially means that a high reactive metal, which is zinc in this case, will be getting corroded, while a lower reactive metal, that is steel, will be protected, and it will act as a cathode, while the zinc will act as an anode. So the pitting or the corrosion will of zinc will occur, while the steel will be still intact and protected, and it'll have a good passivating film around it. The steel will have a good passivating film around it, so that it will remain intact. It will be protected from corrosion. So yes, the third statement is true, and the fourth statement is again wrong, because we want the depassivation of the anode, the zinc metal, so that it will act as a node and it will get corroded. We want zinc to corrode, and therefore it will act as an anode, a sacrificial anode. So we should not, it should not favor the passivation of the zinc metal. So this is a wrong statement. The correct answer are these two statements. Moving on to the fifth question. This is probably the last question of this assignment week. This is a short assignment. Select key features of a good galvanic anode system for applications in concrete structures. Anode tie wires should be die cast into the anode metal. Highly alkaline encapsulating mortar to ensure continued corrosion of zinc anodes. Encapsulating mortar with disconnected pores, and a large surface area of the anode metal to meet the high current demand. Yes, which of
Actually,
these are?
this question has been asked again. It has been asked earlier also in another assignment.
Okay,
You know,
yes. Yeah, I also
anode tie
remember like
wires
we
should.
had discussed something related to
Yeah, yeah,
this
yeah.
in the previous
Yes, yes,
assignment.
yes. This is a repetition, same question as such.
Hmm. Hmm.
It is repeated. Anode tie wires should be die cast. Yes,
Yeah,
it was told in the lecture also.
right,
Highly alkaline encapsulating mortar to ensure continued corrosion. Yes, we require alkaline environment with pH of the order of more than 13 or so for zinc, so that zinc keeps on corroding. Then disconnected pores are not desired, because these corrosion products will require some space in case we have disconnected pores. Those may not be sufficient to accommodate the voluminous products.
right,
Then large surface area of the anode metal to meet the high current demand. Yes, that is also correct.
right,
So third answer is not correct. Others are okay.
right. Thank you, Dr. Satish. Yes, you have rightly answered actually. So the first statement is anode tie wires should be die cast into the anode metal. They should not be welded, or they should not be joined to the anode metal in any other way. Rather, they should be die cast. Die cast means that when the anode metal, that is zinc, is in a molten state, in a hot molten state. Oh, sorry. Just give me a moment. Okay. I was just worried that if I lost all the annotations, like in the previous classes. Yeah. Yeah. So the anode metal, basically zinc in a molten state, and the tie wires are directly die cast. So whenever the zinc is in a molten state, the tie wires are placed in that molten zinc, and after it is cooled down, it hardens, and the tie wires remain intact and form a good bonding between the anode metal and the tie wires. So they should be die cast instead of welding, because if you weld those tie wires into the anode metal, that will the welding metal might be different, and that will create problems in the anodic system, because if the metals are different, as we have also studied, then that will allow for that will create problems like selective corrosion or galvanic corrosion. If the welding metal is reactive in nature, then that will get corroded while the zinc will remain intact, and this will all will create problems. And sometimes if the anode wire, tie wires are not die cast in the anode metal, then what happens is when this zinc metal gets, the anode metal gets corroded, these corrosion products, that is the zinc oxide products, they form around these tie wires, and they create expansive stresses inside the metal, and that will allow for the cracking of this metal, or the cracking of these tie wires, and that will create a loss of connection between the steel and the zinc anodic system. So typically, we should go for SSAP systems where the tie wires are die cast into the zinc anode. So this is a correct answer. Yes. Then highly alkaline encapsulating mortar to ensure continued corrosion of zinc anodes. Yes, this is again true. As Dr. Satish mentioned, the pH required for zinc corrosion is around 13. So for zinc to act as an anode throughout this process, throughout the duration of the for the system to act, we have to provide a conducive environment for the zinc to get corroded, and that environment requires a highly alkaline pH of around 13, and therefore the encapsulating mortar around this zinc anodic metal has to be a active cementitious mortar, so that if the cementitious mortar is in an active state, meaning that the hydration reactions are going on and the hydration products are getting formed continuously, then the pH of the cementitious mortar will remain high, will remain intact, and uh, if the pH is high, then that will allow for the zinc corrosion and for the effective performance of the zinc anodic system. So yes, this is again a true statement. Encapsulating mortar with disconnected pores? No, we do not want disconnected pores, because when the corrosion product or the zinc corrosion products are formed, zinc corrosion products are formed, they should be able to leach out and accumulate at the surface. If they get accumulated inside the galvanic anode system, then that will create since these corrosion products are expansive in nature, they'll expand the volume, and that will create expansive stresses inside the cementitious mortar, and that will create cracking of these galvanic anode systems, and it will get destroyed within a few years. So we want connected pores in the cementitious mortar, so that whenever these zinc corrosion products are formed inside the cementitious mortar, due to the connected pores, these zinc corrosion products can leach out and accumulate at the surface. And when they accumulate over the surface, that will not create any kind of expansive stresses or cracking in the cementitious mortar. So we want connected pores. So this is not a true statement. And the last statement, and that's where I remember that we have already discussed this kind of a question, a similar question probably in one of the previous sessions. Large surface area of the anode metal to meet the high current demand. Yes, a large surface area is required. So as we have discussed, I'll discuss it again. We note that resistivity is equal to Ra by L. So this is resistivity. This is resistance. This is area. And this is length of the resistor. And since resistivity is directly proportional to the resistance multiplied by area divided by L, and we know that um, current is inversely proportional to the resistance. So therefore, we can say that I is directly proportional to A. So current is directly proportional to area, and therefore for to meet a high current demand, we want a higher area of the anodic metal, or else what we can do. So this increases the size of the anodic metals that we're using. Otherwise, the other way around is to go with an increased number of anodes so that we meet the same amount of current demand. So either way, whatever is the more economic way, probably having a large surface area will reduce the number of these systems that we need to install, and therefore that will provide us with an economical solution. So we want a large surface area of the anodic metal. So these three are the correct statements, right? And this ends both the week's assignment questions, the week 10 and week 10, 11 assignment questions. And if you have any doubts, then we can discuss them. Otherwise, the session will go on till 8 p.m. And if you don't have any doubts, we can leave the session.
Well presented.
Thank you. Thank you, Dr. Yes, anybody has any doubts regarding any of the lectures or any of the sessions that we have taken previously? This is the penultimate session of this course. We'll be having the last session in the coming week. We might also have another session after that, not sure. But as per the NPTEL guidelines, the last session is next week, Saturday. That will end the course. All right. I'm muting myself for now. If you have any questions, I can only see the Sentinel is there. If you have any questions, you can raise your hand or unmute yourself and speak. And All right, we are closing the session for today. We'll meet again on next Saturday from 6 to 8 p.m. Thank you.